Hello guys, welcome to today's class. So today we'll be deriving the quotient rule, and we're also going to solve one problem with using the quotient rule. So let y be equals to u over v, where u and v are functions of x and v is not equal to 0, where u and v are function of x and v is not equal to 0. So we can say that y plus So we can say that y plus change in y is equal to, remember, whenever you add change in y plus change in y, the other side, you are going to add u plus change in u over v plus what? Change in v. So now, if we take y to this other side of the equation, we can say that change in y will be equal to u plus change in u over v plus change in v minus, remember, as we take y to this other side of the equation, y is equal to u over v. So we'll say minus what? U over what? V. So now, let's solve this as if we are solving fraction, summing up this fraction. We can say that the LCM of v plus change in v, and v is what? So the LCM will be what? V times v plus what? Change in v. So now, v plus change in v cancel v this, you are left with only v. So we can say that we have v bracket u plus change in u. Now v cancel v cancel v, we have only v. So we can say this times u gives you what? Minus u v plus change in v. So now if we open the bracket, this is equal to v times u give you what? Uv. V times plus change in u give you what? Plus v change in u minus u times v gives you a minus uv, minus u times plus change in v gives you what? Minus u change in v. Now, minus u change in v and plus v change in, minus uv and plus uv can cancel out. This can cancel out. Forget, this is over v plus what? Change in u. Sorry, change in v. So we are left with u, v change in u minus u change in v over v bracket v plus what? Change in v. So now we can, if we divide through by changing x, we can say that changing y over changing x is equal to v changing u over changing x minus u changing v over changing x divided by v plus what? Changing v. So now don't forget that as changing x tends to 0, likewise changing u will tend to 0, and changing v will also tends to what? 0. And now we can take the limit when changing x tends to 0. We say the limit when changing x tends to 0 of changing y over changing x is equal to the limit when changing x tends to 0 of v changing u over changing x plus u, minus, this is supposed to be minus, u changing v over changing x divided by v times v plus changing v. Now this will be equal to v, the limit when changing x approaches 0, changing u over changing x minus u, the limit when changing x tends to 0, changing v over changing x, all divided by v, all in bracket, v plus changing v. So now we can say that hence dy dx will be equal to v. Remember, changing u, changing v is still the same as what? Du dx. So you can say du dx minus u, changing v over change x into the v dx. So dv dx divided by v square. Remember that this is 0, so this change in v is 0. So if you multiply everything here, this is just v square. So this is the rule for, this is the quotient rule. This is the quotient rule. It states that dy dx is equal to, using the quotient rule, v times changing u over changing x minus u times the v, which is changing v over changing x, divided by what? V square. So now let's try one example using of 1 plus x square over 1 minus x square. So now, seeing this alone, you know that is what? It has to do with quotient. You apply what? The quotient rule. So you can say that starts when one starts, you can say that given that whenever you see y is equal to u over v, the rule states that dy dx is equal to v du dx minus u dv dx divided by v square. Now what is u? Stating that u is what? U is equal to 1 plus x square. You can choose to call it what? Equation 1. And v is equal to 1 minus x square. You can also choose to call it what? Equation 2. Now, if you say from equation 1, this equation 1, du dx will be equal to, if you differentiate 1 plus x square gives you 2x, will be equal to what? 2x. And also from equation 2, dv dx will be equal to, differentiate dv dx, you have what? Minus what? 2x. So now, since we've gotten what u, v, du dx, v is dv dx, so we can just apply what? The quotient rule. By stating the quotient rule, which states that dy dx is equal to v du dx minus u dv dx over v square. Now, what is v? V is 1 minus x square. What is du dx? Du dx is equals to 2x. This is minus, what is u? U is 1 plus x square. And what is dv dx? Dv dx is what? minus 2x. Don't forget that this is all over v square. What is v? V is 1 minus x square. So now 2x times 1 gives you what? The y dx is equal to 2x times 1 gives you what? 2x. 2x times minus x squared gives you what? Minus what? 2x cube. So we have minus sign here already. And we can say that minus 2x times 1 gives you what? Minus 2x. Minus 2x times plus x squared gives you what? Minus 2x cube. So we can use minus to multiply everything inside the bracket. We'll have is equal to 2x minus 2x cube and cube. Minus times gives you what? Plus 2x. Minus times gives you plus what? 2x cube. This is over 1 minus x square bracket square. So now the y dx is equal to, this can cancel out this. So we have that 2x plus 2x gives you what? 4x over 1 minus x square raised by square raised by 2. So this is the derivative of this question. So please like, share, and subscribe. On our next class, I'm going to talk about still applying this quotient rule, but we are going to find derivative of difficult questions. So also on our next class, we'll also talk about implicit differentiation. Like, share, and subscribe.